the labels are required for training, whereas in clustering algorithm, no need for learning. So the labels are not required. Only the data is enough for clustering. The example is detect patterns, group email or search results based on the customer requirement, customer shopping patterns. These are some patterns used for clustering. This clustering is very much useful when we don't know what you are looking for. Basic idea of the clustering is to group the similar objects. The clustering algorithms are classified into partition clustering algorithms as well as hierarchical clustering algorithm. A partition algorithm, K-means clustering, mixture of Gaussian, spectral clustering. These are some kind of the partition algorithms. Whereas hierarchical clustering means bottom-up clustering as well as top-down clustering. Example for bottom-up clustering is agglomerative clustering algorithm. In that we drawn the dendrogram. Then top-down algorithm is divisive algorithm. Facial friend suggestion is Facebook friend suggestion is example for top-down clustering. Some examples are image segmentation, gene data segmentation, and the first kind of clustering is K-means. Already we discussed about the K-means clustering. Select the random point, find the Euclidean distance. Based on the Euclidean distance and number of clusters, group the data point into various clusters. That is the concept of K-means clustering algorithm. In the K-means clustering algorithm, the optimal value of K can be selected by using the elbow method. Elbow method is used to find the optimal number of K. K-means clustering is mainly used for segmentation problems. If you are giving K equal to 2, only 2 partitions, yellow shape as well as blue. Here, if you give K equal to 3, yes. It's divided into 3 partitions. You know the concept of K-means clustering algorithm. And the next one is the agglomerative clustering algorithm. Remember that in the agglomerative clustering algorithm, each and every data point is treated as the cluster initially. Initially, all the data points are treated as a single cluster. Then they are combined based on the similarity, and finally you will form a single cluster. In the agglomerative clustering, we use different linkage criteria. First one is the single linkage criteria, complete linkage criteria, and the mean linkage criteria. The single linkage criteria is closest pairs, that is the distance between 2 pairs or less, that's considered in a same cluster. In complete linkage, a fastest one is taken, that is the distance between these 2 points are high, that comes under a single cluster, whereas the average point clustering, the mean value is taken into account. Here, grouped, and again entire groups are combined to form one group. Then already I told you the difference between the hard clustering and the soft clustering. In the hard clustering, each and every point is belonging to only one cluster. In soft clustering, it can be combined. A point can be included in cluster X or Y. That is clustering in the hard clustering. Again, next type of clustering is the divisive clustering or graph clustering. In the graph clustering, the agglomerative clustering is example for bottom-up clustering, whereas graph clustering is example for top-down clustering. Initially, all the data points are considered as a single point. A single cluster, all data points comes under a single cluster. Then that is divided into so many clusters based on the requirement. That is the concept of graph clustering. The graph clustering is otherwise called as, it's a type of divisive clustering. Divisive means from the whole you are dividing it into many. That is the divisive clustering. Here, a group of data is divided into subsets. For example, consider in this example, there are objects with oval shape as well as the rectangle shape. Here, based on the shape you are clustering means it comes under these two clusters. But based on the color, if you are clustering, this means it comes under three clusters. Based on the features given by the user, it can be classified or clustered into two or many clusters. And graph clustering is the type of the divisive clustering. Here, each and every element to be clustered is represented as a node, and the distance between the two elements are called as the weight. Each and every one is called as the node or the vertex, and distance between these two are known as the edges or the weights. Based on the edges or the weight, they are clustered. For example, there are two types of clustering for graph clustering: between graph clustering and within graph clustering. Between graph clustering means clustering a set of graphs. So many graphs are there, and that graphs are clustered means that's called as between graph clustering. Here, a set of graphs are divided into so many clusters. For example, consider the chemical components. Based on the structure of the component, it can be divided into so many clusters. That is example for the between graph clustering. Another one is the within graph clustering. Within that graph, that based on this weight matrix, that is cluster means that is called as the within graph clustering. Divides the node of a graph into cluster. For example, social networking. People with similar hobbies or similar character. Some examples in Facebook and all, it can cluster based on the location. If based on the location, from different clusters they are combined means that is called as within graph clustering. For all this kind of clustering, we need the adjacent matrix. The adjacent matrix is formed between the nodes and all. Here, when you consider this example, here there are 4 nodes, 1, 2, 3, and 4. For all these nodes, the adjacent matrix is formed and the weight is entered here. Weight matrix is calculated. And then the Laplacian matrix for the adjacent matrix is found using the given formula. First adjacent matrix, then the Laplacian matrix, and then the eigenvalues are calculated. From that is formed in a graph. That is the concept of graph-based clustering. Each and every clustering has its own advantages as well as the disadvantages. Now you go and do the quiz that is related to this clustering. I have posted in the GCR. Just go to that quiz and check whether it is working or not. Take the quiz, go to the GCR and check whether the quiz is working for you or not. Is it possible to do the quiz? Joel, go to GCR and check whether it is possible to do the quiz or not. Anyone go to GCR and check whether it is possible to do it. Otherwise, I'll share you the code, quiz code. I have assigned a quiz in the GCR. Do it before coming to the next class. The next topic is the recommender system. I know that you are familiar with the recommender system. What do you mean by recommender system? Can you say some application of the recommender system, some example for recommender system? Everyone give you some example for recommender system in the chat box. Why you are this much irresponsible, students? Say some example for the recommender system in the chat box. You type the example for the recommender system. Can you hear me? Joshua? Pinakas?
Ma'am?
Can you hear me?
Yes, ma'am.
Yes, ma'am.
Then I am asking about the example for recommender system. Type the example for recommender system in the chat box. Simply you are all sitting. What's the use of that? Okay, give the example, then I'll go for the. Give some example for what is recommender system. Okay, Pinakas, YouTube. All of you give your example for the recommender system. Only Pinakas and Kogulnas is there. Remaining. Or is the remaining students? Just give an example for recommender system. If you are not willing to interact with this one, I won't call you for the attendance also. Keep silence. That's enough. It's easy for me to give attendance also. Just I'm asking whether the quiz is working, no response. Then recommender systems give example, no response. Nothing is there means no. What's the need for this class then? Before ending this class, you should give the example for the recommendation system. All of you should give the example for recommendation system. From that, I will give you the attendance. I need to give the attendance. Okay. The recommendation system based on this user recommendation. Based on the usage of user, the system will recommend something to the user. That is called as the recommendation system. The recommendation system works based on two concepts, collaborative filtering as well as the content-based filtering. Before that, there is a difference between the search engine as well as the recommender system. Example for search engine is the Google. Google is example for search engine, whereas the Flipkart, Amazon, then your Redbus, all are example for the recommender system. The search engine is the pull system. By using some keywords, you are pulling the information. So search engine is a type of pull system, whereas recommender system is the type of push system. Push system means if you, without doing anything, without asking anything, it should push something to your view. That is the concept of the recommendation system. And the search engine is the user initiative. User only initiate the operation. Then that is called as the search engine. It works based on the keyword. But the recommendation system is the push system. This is the system initiative. The products are initiated by the system and it provides recommendation based on the past preferences. No need to search with the keyword and all. Instead of that, it provides recommendation based on past preferences. Main task of the search engine is to respond to the query, whereas recommendation system shows only those items which are useful for the users and discard the others. It's one of the application of machine learning. It's used in different ways in the daily life. A recommender system is defined as a tool designed to interact with large and complex information spaces capable of predicting the future preferences of a set of items based on a user view. Automatically, it will show you the information by the prediction algorithms. Example is movie recommender system, product recommender system, and other examples are LinkedIn, Facebook. These all are examples for recommender systems. Why and when we do the recommender system? In the internet, quantity of information is huge. Quantity of information is huge and quality is also a significant need. People are not able to be experts in all the domains. If you're expert in some domain, you're not interested in other domains first. But the recommender system will recommend all the items. It's really interesting when dealing with the following issues. Solution for large amount of good data. And Amazon, if you want to purchase a shoe, a large quantity and quality of products are there. It depends upon your interest. You need some recommendation, means it can be done with the help of the recommender system. It reduces the cognitive load of the user and allowing new items to be revealed to users. New items with the same cost and same preference also can be revealed to the user by the use of the recommendation system. The data required for the recommender system come from explicit as well as implicit analysis. Explicit means user rating, commands, like. Based on our commands, based on our like, it can recommend some products to you. Similarly, it search queries, purchase histories, and other information. Based on this history also it can recommend. That is called as implicit. And it can two kinds of information it takes: characteristics information and the user item interaction. First one is the characteristic information, that is keyword, categories, and the user. Based on the preferences, it will recommend something. Then user item interaction, user likes, user rating, number of user purchase the particular item. So recommended system works based on your characteristics requirement as well as the user item interactions. There are two types of recommender system: content-based filtering and the collaborative filtering. Another kind of recommender system is the hybrid recommendation system. Here, a content-based recommendation system as well as the collaborative recommendation system both combine together to recommend the items to the user. In this one, for the recommendation system, we need the item profile as well as the user profile. Item profile means, suppose you are searching for the movie, means movie author, movie title, actor, director. Depends upon this movie content also required. And the user profiles, which kind of users are you watching, which kind of movie. Children means which kind of movie is preferred by the children, for youngsters, for adults, what kind of movie can be continuously viewed by such kind of people. So user profile is also very, very important for the recommendation system. Item profile as well as the user profile is important. Suppose I like the grilled chicken, means a chicken variety. Item profile, what are the types of chicken, what's the calories in that, what is good for health, everything, taste, everything. User profile as well as the user profile, which kind of user is preferring this one, in which age group they are preferring. Suppose the age, if the item is very good and the age group is above 60, means they won't prefer the items. So depends upon the group of people and depends upon the item only that content is recommended to the user. Then the recommendation, not only the purchase thing taken into account, but the viewed things also taken account for this recommendation system. Sometimes we view the things based on our recommendation, we will review that, but sometimes only we purchase that. So when you are calculating this recommendation for a particular user, the Boolean expression between the viewed as well as this bought is taken into account. Similarly, star ranking is also taken into account. Up-down expressions like this, like all these things are considered, and number of times that's viewed, that's also taken into account. You're watching one song, means how many times you watch that song, how many times you view the movie. That's also taken into account when you are generating this recommendation system. The first one is the content-based filtering approach. Consider user A brought the product, a mobile phone, a good mobile phone. User A brought that particular mobile phone. And then the similar items are recommended to the user A. That is the, in addition to that, you can purchase some headphones, AirPods, mobile pouch, or the speaker. Something else can be purchased along with this product. So that is called as content based. If the mobile phone means, the content related to that items are also recommended to the people which are similar or related to the user like before. Content-based approach use profile about user preferences and descriptions of item along with user item interaction. The next is, for example, music recommendation system. Item description, I already told you, item description, music director. If I am watching the Ilayaraja music continuously and I am in the particular age group and I am a female, that kind of songs will be recommended for me. That is the content-based filtering. Based on the requirement, it's displayed. Movie recommendation system, similarly, based on the star rating as well as the age group and the contents, the same thing is recommended, means that is movie recommended. For example, you already watched Jurassic Park 1, 2, 3, then Jurassic automatically 4 is recommended for you. If you read the book Harry Potter 1, 2, 3, and then the next one is also recommended for you. Based on the content, the thing is recommended, means that is called as content-based recommendation. Here we need the text features as well as the frequency of terms. How many times it's watched. The recommendation system, the similarity between the users are calculated by using the cosine similarity. Already we discussed the similarity can be calculated by using the Euclidean distance. Similar way, in this recommendation system, the similarity is calculated by using the cosine similarity. The next is we will solve the problems in this cosine similarity, the next class. Then collaborative filtering approach. In this approach, consider A and B are similar users. Suppose A is interested in mobile phones and user B is also interested in mobile phones. If user A bought one headphone, means that is recommended to user B also. Suppose consider A and B likes chicken. A is eating which one? That grilled chicken, and B is eating chicken tandoori. Then if user A bought extra mayonnaise or jam, that is also recommended to user B. That's the concept of collaborative filtering approach. For similar users, if one of the user purchased a new item, that is also recommended to user B. Suppose Coursera, you are doing 2 courses, you are doing artificial intelligence and this data science. Some other person is doing data science and operating system. In that situation, we both are doing data science. So the operating system is suggested to user A and machine learning is suggested to user B, vice versa. The remaining course is also suggested to other user. That is called as collaborative filtering approach. That is, in collaborative filtering approaches, recommended new product based on the past interactions recorded between users and item. Similar users share the same interest, assuming that similar user having the same interest. It's one of the most commonly used recommendation system than the content based. In collaborative, there are 2 types: user-based recommendation and item-based recommendation. One of the main advantage of this collaborative based system is it does not need to understand what the item is recommends is what item we should recommend to the user. No need to understand that. Instead, if A is liking this one, then automatically you will say B will also like this one. That's the concept of the collaborative filtering recommendation system. Main drawback of this kind of method is the need for a user community as well as a cold start effect for new users in the community. Cold start effect means if the new user is entering inside the community, then it's difficult to recommend the system for that. For existing user, we know their frequency and their interest, so we can recommend the systems to them. For the cold start effects, System cannot infer the recommendation for the new users. That's a drawback of the collaborative recommendation system. But content based, no problem, because based on the content they are searching, we can recommend a new items to them. For all this recommendation system, we need a utility matrix. From the utility matrix only, the contents are derived. The utility matrix, the similarity is identified by using the similarity score, and the similarity score is calculated by the cosine similarity method. The cosine similarity, there are two types, cosine similarity and the Pearson cosine similarity. Based on that only the rating is given. The difference between the collaborative recommendation engine and the content-based recommendation engine are, in the collaborative recommendation system, it emphasizes on the user preferences, whereas content-based recommendation emphasizes on the content features. Collaborative based on the user preference and the content based on the content features. In the laboratory, we will execute the content-based recommendation system. In collaborative filtering, a recommendation engine requires the user profile to suggest relevant content. In content-based filter, no need for the user profile. Instead, the content is enough for recommending the system. The collaborative recommendation system feed on the user ratings, reviews, thumb ups, downs, and other feedback on various products and services. So the products with no rating or feedback can't be recommended to any user. Neither a new user who hasn't given any review or ratings can get any recommendation by the collaborative recommendation engine. This is called the cold start problem. The content-based recommendation system are product feature oriented and hence don't have such a problem. No need to see the review and all. It's purely the product oriented. In collaborative recommendation does not always ensure precise recommendation, because the user with similar taste may not like the same products always. We can't say that. Suppose in the mobile you are having the same taste, both of you can like iPhone, but when you are going to purchase the dresses, somebody may like Alan Shirley or somebody may like the Louis Philippe. Depends upon the user. We can't tell that the likings is same for all the products. So that is the drawback of the collaborative recommendation system. Whereas in the content-based recommendation engine can provide more accurate recommendation as it focuses on the features of the content as a user like. Okay. That is, if you're one time you're purchasing Alan Shirley, means next time the same kind of dresses can be recommended to you. You can develop a recommender system also. It is all about the recommendation systems. We solve the problem in the recommendation system later classes.